So reviewing the 5 ways to prove triangles congruent, here we are today. We should have them down, side, 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 angle, 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 side, and hypotenuse leg. Those are all congruent theorems. Today, we will not prove triangles congruent. We will prove them similar instead. There are only 3 ways to do that. This way, yes, we will have side, side, side similarity theorem. I'll get you a note sheet in a second. Just wait, okay? We will also have side, angle, side similarity theorem. These two get meshed together. What do you see that's common between angle, side, angle, and angle, angle, side? What do you see? It's got 2 angles the same, so it's called angle, angle similarity theorem. Hypotenuse leg, no thanks. It's the same thing as like side, 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 side. You don't need to do it, okay? So it's just these 3. What do they mean, though? Side, 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 okay? So just for example, I got to have 2 triangles. Well, that's a horrible sketch. And I have to have 3 sets of sides that I know in each triangle, and I have to get the same scale factor back every time, right? They got to be proportional. Aren't those the 2 rules to be similar? So if I look at this to this, wouldn't you assume that they'd correspond to each other? What's the scale factor if you go big over little? 2 to 1, right? What's the scale factor if you go big over little? 2 to 1. What's the scale factor if you go big over little? Worked all 3 times, right? It's not called side-side similarity. It's called side-side-side. You got to get it 3 times in a row. Did we get the same scale factor back all 3 times? That means that's enough information to prove that those 2 triangles are similar. I don't need to know anything about the angles. It would force them to be the same. And if you kind of remember that the smallest angles across on the smallest side and stuff like that, it just forces them to all be the same. If you had side-angle side similarity theorem to where it would look something like this, dude, having a good day. You go a side, then an angle, then a side. The angles have to be congruent to each other. Remember, part of the rules for similar figures is corresponding angles must be congruent. But the sides, again, have to be proportional. Don't you get the same scale factor back of 2 to 1, 2 to 1, and the angles in between those, like a side angle side orientation, is exactly the same. Those 2 triangles are similar by side angle side similarity theorem. Now, why would you call the other one angle angle instead of angle angle angle? Like, why wouldn't you use 3 A's? So, like, let's just say that I had 90 degrees and 30 degrees and 90 degrees and 30 degrees. This is enough right there to prove those 2 triangles similar to each other, right? Because don't I have 1 set of angles congruent to each other and another set of angles congruent to each other? Why don't I need the 3rd set? Because you know what it has to be already, right? If this is 90 and this is 30, what does this one have to be? 60, and then doesn't that force the hand up here? You only need to know 2 angles out of the 3 because the 3rd one is just like a moot point right there, okay? Moot point, whatever it's called. So let's try our practice a worksheet. First thing you should do when getting a practice worksheet is write the 3 ways to prove triangles similar to each other. We will not actually do T-chart proofs. We will just answer some questions. Do we have? What are the 3 ways? What's the first way? Side, side, side. But this symbol means what again? Similarity theorem. The other one is what? Side angle side similarity theorem. And finally, the 3rd one is angle angle similarity theorem. And get ready for what you will feel to be probably one of the easier practice worksheets compared to one of the hardest homework sheets that you will have. Your comfortability level will kind of fall through by the time we're done. It'll start out really simple, and then it becomes a mess, all because of the pictures. See those 2 right there? Is it pretty easy to see what would correspond with what, just the way the picture's drawn? But oh man, when they're kind of overlapping each other a little bit, or they're not turned the same way, they got different orientation, you want to start pulling your hair out. It's like, holy cow, it's hard to see. So here's what we're going to do first. Do we know if these are similar to each other in the first place? Do they straight up tell us that? Nope. I'm going to do this. It's quite obvious, but I think that's helpful. Big and little. It's like we did before. Out of these three possible ways to prove them congruent, what do you feel we would try? Side, 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 angle, side, or angle, angle? Being how we have sets of sides, right? We have 3 in one and 3 in the other. I would try side, side, side. We're going to do something totally illegal here, against the rules of mathematics, but it's very helpful for our eyes. Let's mark the sides that correspond to each other with tick marks, okay? Wouldn't you believe that the longest side in this triangle should probably correspond to the longest side in that triangle? Wouldn't that make sense? So longest guy here, 42, put a tick mark on it, and longest side over here is 12, put also a tick mark on it. Why is that mathematically wrong to do that? Tick marks mean they're the same length. Those are not the same length. I am just marking what corresponds with what. So if some other math teacher or math person says, hey man, you're doing that wrong, just go, I understand that. All I'm doing is marking what corresponds with what. Wouldn't you think medium would correspond with medium? Who's the medium guy? 28, right? That's the second longest one. So 2 tick marks, and medium guy over here is 8, 2 tick marks. And then finally, it's worth your time to put those 3 tick marks, 3 tick marks. Of course, you could see very easily what corresponds with what in this picture. I'm showing you what to do when things get tough, right? When you're not sure, marking them up. Now, here's what I need to do. I need to see if I get the same scale factor back all 3 times. Well, we don't need to set up any proportions or anything like that. All we got to do is grab the ye old calculator. Let's punch it in. How do you want to punch it in? Big over little or little over big? Well, let's do 42 over 12. 42 divided by 12. What do you get? 3.5. You can have a decimal. We're not going to set up a proportion. Just what did your calculator tell you? Didn't it tell you 3.5? Right? If you get 3.5 back again and again, then we're good to go. Make it a sense? So, what do you want to try next? 28 over 8. Let's see if we get it. 28 divided by 8. Do you get 3.5? Is that enough? Nope. That's only side to side. You need one more set to see if that works. Do 21 over 6. Do you get 3.5? Are these two triangles similar? Yes or no? Yes. By which method? Side, side, side similarity theorem. And then they ask us to write a similarity statement. So, I see my 3 favorite letters when it comes to a triangle, A, B, and C. Let's call the first guy triangle ABC. It is similar to triangle. I'm going to put the other dude in corresponding order. Again, I hope you believe me that the homework will be much harder than this worksheet. So here's how to tell what corresponds with what. Doesn't A come first? Can you see in the picture, point A is where the 1 tick mark side and the 2 tick mark sides come together. Where does the 1 tick mark side and the 2 tick mark side come together? There. At D, and then B corresponds with E, and C corresponds with F. But when you can't see what corresponds with what, look to the tick marks and see what order they should go in. Nice? Let's try the next one. Boom! Which way would you try out of those 3? Side, 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 angle, side, or angle, angle? So let's try it. Let's mark it up. Long guy, boom. Goes with long guy, big and little, of course, you know, so we can do it the same way. And then, whoa, man, another 27. Like, how many tick marks would you put on it? Same amount, right? But the 8th, that's the shortest side, if you will, or the medium guy, whatever you want to call him. Let's do it. Punch in your calculator for me. Let's see if we get the same scale factor back all 3 times. 27 over 15. Punch them in. What you got? 1.8. I pray that you can understand that if you do it again, 27 over 15, you would get the same thing, right? Please don't do too much work. But is that enough? You got to do 8 over 5 also. 8 over 5, do you get that 1.8 again? No. Are those 2 triangles similar? No similarity. Well, wait a minute. That just meant that side, side, side failed, right? Could we try something else? Can we get some angles? Like where would we get some angles the same at? Oh, these are isosceles triangles, right? So shouldn't these angles be the same? What do you think? Should those two angles be the same? Yep. And shouldn't these two angles be the same? Now here's my thing though. Do you know that angle H has to be the same as angle J? You don't know that, right? You know that H and I have to be the same and J and K have to be the same, but you have no idea if H and J have to be the same. So it's not, do you have two sets of angles congruent to each other in the same triangle? It's when you go from big to little, does this angle which corresponds with that angle, are they congruent to each other? Yes or no? No. So this is a no similarity. Angle, angle fails. We don't have enough information to do that. Because that's eight witches. So on the next one, we'll start out with a little big and little. Tick them up. What corresponds with what? I always go long, medium, short. That's kind of how I roll. So long one, medium, medium, shorty, shorty. Which way would you try? Either side, 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 angle, side, or angle, side, angle, or excuse me, angle, angle. Give it a shot. Just see if you get the same scale factor back all 3 times. All right, so 63 over 42. And then doesn't 60 go with 40? Now watch this. And then I got 1.5 and 1.5. And 10 and 15, don't they go together, right? Oh, I didn't get 1.5 back. I got 0.6 repeating. Oh, I did what? I did little over big instead of big over little. You got to make sure you divide each way. Don't you get 1.5 when you do 15 over 10? Are they similar to each other? Yeah. Yep. By side, 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 similarity theorem. Now, let's call the first triangle the same thing. What do you want to call this guy over here? Triangle, that one with the M-O and the N. What do you want to call it? M-O-N would be fine. You can name the first one whatever you want. Second one's got to go in corresponding order. You can see that they're not exactly identical side by side. There's a little bit of a reflection going on there. So figure out what corresponds with what by looking at the marks if you need to. What does M correspond with? Isn't M where 1 tick mark and 3 tick marks come together? Isn't M where 1 tick mark and 3 tick marks come together, correct? What does it correspond with? What's it correspond with? It goes with R. A lot of people would assume that it goes with P because it's like, oh, this is at the top, that's at the top. But where do 1 tick mark and 3 tick marks come together? At R. I'm telling you, it's tougher than you think it is, and this is an easy tough one, if you will. What does O correspond with? Isn't that where 3 and 2 come together? Where do 3 and 2 come together at? At P, and N has to go with Q then, because that's the only one left. But use the tick marks to help you see what corresponds with what. Okay? Next. Oh, dude. Got 2 triangles there. I don't see the pictures though, but you got lengths. Do you have all 6 guys represented? So wouldn't you try side, side, side out of that situation? Now let's do this. Here is 24, 42, 51. Out of these 3 in triangle ABC, what's the longest one? Put a box around it. Find the longest one in the other guy, put a box around it. What would that be? 85. Correct? And that means they correspond to each other. Medium guy, don't put a box around it. Right? Let's do this. Medium guy is 42. I will circle it instead. Some sort of different marking. Shouldn't that correspond with the 70? Right? And then the other 2, I'm not going to put anything around it. They go together. Long guy goes with long guy. Medium guy goes with medium guy. Short guy goes with short guy. Who's the bigger triangle? How did you know that triangle DEF is the bigger triangle? So big and little, right? Let's see if we get the same scale factor back all 3 times. If I use 85, what does it correspond with again? 51. 85 over 51 is how much? 1.6 or 1.6 repeating? 1.6 repeating? That's okay. Let's see if we get that back the other two times, right? So 70 over 42, do you get 1.6 repeating again? And finally, 40 over 24, do you get 1.6 repeating? Yep, so they are similar. By side, 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 similarity theorem. To write the similarity statement, it is probably easiest to sketch a picture. Triangle A, B, C. And the other one's bigger, right? Triangle D, E, F. You could have done this to start with, but it doesn't really matter. Distance from A to B. I'm just going to start with it. I'm going to put one tick mark on it. Distance from A to B. What did it correspond with, though, in the other triangle, distance from A to B? Distance from F to D, right? Doesn't it? I'm sorry, you're right. E to F. E to F, right? Those. So I'm going to find that and put one tick mark on it. You with me? Then B to C is 42. That corresponds with F to D, which is 70. And then finally, triple and triple. Now, let's name the first triangle, triangle ABC. It's similar to triangle. What does A correspond with? Look at your sketch. A is where 1 and 3 come together, right? Where do 1 and 3 come together in the other triangle? Right here. 1 tick mark, 3 tick marks come together at E. Continue. I sketched a picture and just marked my guys that were corresponding to each other. B is next. B is where 1 and 2 come together. 1 and 2 come together at F. And finally, the last thing is a D. How do you feel about that? Yes? No? Maybe? Number 5 is very similar to it. We won't do that one. Let's go to 6. What do you think? We can big and little them to start. Side, side, side. Can we try it? Why do you say no? Well, there's sometimes when you have a triangle and you know two sides, you can find the third side pretty simply. If you know two sides of a triangle, sometimes you can find the third side. When does that happen? If it's a right triangle, you can use Pythagorean theorem. Are these right triangles? I don't know. So side, side, side? No thanks. How about side, angle, side? You got any angles? Nope. Angle, angle? Well, we already know we don't have any angles. So what do you think? Are they similar? No similarity. They might be. You know, we don't have enough information to say that they're not. We just can't prove that they are. Next. Big and little. I'll let you and the pal discuss here for a moment. What do you think? If you was to try any of those three ways, which ways would you feel like trying? Well, side, 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 you have to know all 6 side lengths. 3 from one triangle, 3 from the other. You know 21, you know 14, and this guy is represented by 3 halves x, and 12, 18, and x. But do you know what would correspond with what? What's the longest side in this triangle? How do you know the 3 halves x is longer than that? Like, how do you know that 21 is longer than 3 halves x? How would you find x? You can't do the scale factor thing unless you know they're similar in the first place. Cool, that's a good point. People are like, well, what if you find the scale factor? You can only do that if they're in the first place. We're trying to prove them similar first. Do we have enough information? Do we know that 21 is longer than 3 halves x? I have no idea. How do I know what would correspond with what if I don't even know how long they are? People would assume. They're just like, well, shouldn't these go together because they both have an x? Why? Why do they have to correspond to each other? There's no reason that says that they have to correspond to each other just because they both have x's with them. Long corresponds with long, medium with medium, and short with short. Can you prove to me in any which way which one's the longest guy? So what do you think? Can we do side, side, side? Side, angle, side. Can we do it? And then angle, angle? No. Similarity. Can't assume anything. Backside. Are the following figures similar? If yes, by which method? List the similar triangles in order. Let's do number 1. I'll let you look around at it. See what you think with the PAL. 1. 3 ways. Side, side, side. Can you try side, side, side on number 1? No side length whatsoever. So that means side, angle, side is also most likely out, correct? Angle, angle is the only possibility. Can we do it? Well, I definitely see a 60 and a 60, right, from one triangle to the next. There's one set of angles the same. I need a second set of angles the same to get that done. This is a 61. That's a 59. Obviously, they are not congruent to each other. But can you find a missing angle in the triangle? If you know 2 angles in a triangle, can you find the third one? How much is this one got to be? 59 degrees. Because all 3 of them add up to 180, right? And now double arc, double arc. Do you have enough information to prove these 2 triangles similar to each other? So similar? Yes. Method? What was our method? Angle, angle, similarity, theorem. Triangle ABC is similar to, this one's real easy to see what corresponds with what. You match the angles up. A comes first. Isn't A the 61 degree angle? It should probably go with the 61 degree angle in the other triangle, which is which one? Don't forget the triangle symbol in front of it. B goes with D, because they're both 60s. And finally, C goes with F, because they're both 59s. Easy to tell. You didn't need any tick marks. You had all the angles. Good deal? Over to 2. Interesting. I have absolutely no side lengths. I have absolutely no angle measures provided to me. The other thing is, I will assume that we can at least see that this is one of the triangles they are talking about, correct? And please, please, please watch this. See this? Come on, please work. Do it for me, dog. See that? Is that a triangle? No, it's not, right? This is not a triangle. We are looking at big boy, right here, and little boy. Do you see the 2 triangles in this picture? Those are what we're trying to prove similar to each other. I have no information, though. No sides, no angles. Anything given to us, though? It gave me parallel lines. And what do we get from parallel lines? Parallel lines implies blank. Corresponding angles congruent, and also alternate interior angles. When they give us parallel lines, we get angles from them, correct? So, check it out. Here's my parallel lines. Can you make yourself a set of arc marks that touch those parallel lines and touch the same segment for a transversal? Get it done. What do you think about those 2? Do they touch the parallel lines? Yep. Do they touch the same segment that's not highlighted red for a transversal? Nope. So no dice here. If I pick on this guy, what if I put those right there? Do those each touch the parallel lines? Do they touch the same segment for a transversal? What kind of angles are those? Are those corresponding angles or alternate interior angles? Awesome. So far in the triangle, I got one set of angles the same, from little triangle to big triangle. Can I get another set? Marking them correctly would be the hardest part about this. How many arc marks would you use? Boom, 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 boom. Aren't those also corresponding angles in this situation? Are those triangles similar? Yes or no? Yes. Which method? Angle, angle, similarity theorem. Triangle ABC, A goes with B goes with D, C goes with E. Give it a shot. A, D, E. Nice. Triangle ADE. Number 3 is all yours. Please pause the video and get that done. The way I would try would be side, side, side. Just because you have all 6 things doesn't mean it's going to be side, side, side. You should see if you get the same scale factor back each time. I could do it without a calculator because 28 over 7 is 4. Pretty sure 20 over 5 is 4, and 16 over 4 is 4. So you get the same scale factor of 4 back all 3 times. So these are similar by side, 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 similarity theorem. What does P correspond with? Z. For those who are still kind of struggling, because that's all right, here's point P, right? You see that it is the intersection of these 2 segments right there. The segments with 3 tick marks and 2 tick marks on them. If you go to the other triangle with the segments with 3 tick marks and 2 tick marks, don't they intersect at point Z right there? That's what it will correspond with. What does Q go with? 1 and 3 is X, and then finally Y, because I asked you so. Next, similar, yes or no? They gave me some side lengths. Do I have like all 6 of them? You can see in this guy, right, that missing the bottom dude, missing the bottom guy here. Do you also see the 2 triangles that we are trying to prove similar to each other? Those, right? You all good with that? So, can't do side, side, side. I don't have enough sides. Wait a minute. 6, 8, should that be 10? Because 6, 8, 10 is one of them Pythagorean triples we've talked about, like 3, 4, 5, and 5, 12, 13. If this is 6, and this is 8, does this have to be 10? The answer is no. It will be 10 if, what? If that's a right angle. Do we know if that's a right angle or not? So it doesn't work that way. It's got to be a right triangle first. So, all right, can't do the side, side, side thing. Can I do angle, angle? Well, we did it up here. How did we do angle, angle up here? What did they give me? Parallel lines. Even though these look parallel, do they have the arrows on them? No, so we can't do that. So side, angle, side would be the way I'm thinking. It's like, because I have some sides, if I could get an angle somewhere, like to where I know that angle has to be the same from the little triangle up top to the big triangle, from green triangle to red triangle, do you see anywhere where I know an angle just has to be the same? Where at? Why? It's shared between itself. So if you was to justify why angle C is congruent to angle C, what justification would you use? That's the reflexive property that says that that's the same. So mark it. You got to put that mark in there for me so I can see. Is that enough? Does that mean, yep, they're good by side, angle, side? Yes or no?
No.
No. Hang with me here. I know you're getting a little bored. One more time. Is this a triangle? Yes or no? No. This 4 and this 3 don't have much to do with what we're trying to deal with. We need this. Please draw this. Put a little bar right here. I need to know how long that entire side is right there. How long is it? 12, 8 and 4 together, and do the same thing over here. I'm going to make you do this so you can at least understand what's going on. How long is that? Now I need to see, to do side, angle, side, I need to get the sides themselves have to be in proportion. What does it correspond with? 4 or 8? 8, right? The side in the little triangle. 12 over 8. What do you get? Punch it in. 12 over 8. 1.5? What's the other ratio you would check besides 12 over 8? 9 over 6. You better see if you get 1.5. Do you? So are these triangles similar? Yes. By side, angle, side, similarity theorem. Because I got a ratio of 1.5 here, I got this angle in the middle, and then I got a ratio of 1.5 there, or 3 over 2, whatever you'd call it. And then ABC, A goes with D, B goes with E, and C goes with C. Nice. 3 more. Finally, they ask us to solve for the unknowns. That's what you were doing when you handed your homework in today. You like find X, find Y, find this, that, the other. The only thing that you knew ahead of time was you already knew that they were similar because they told you to. I want to ask you one question. Wouldn't it suck to do all this finding of x and y, and the two triangles weren't even similar in the first place? Everything that you did was for lost time. You must prove the two triangles similar first. How can I prove these two triangles similar on number 5 here? I can't do side, side, side. I don't have this side right here. Side angle side, I can't do side angle side. Here's that shared angle, but see, this is missing. That's an x, right? I don't know that one. So I got to vote for angle, angle. I'd really like to know where we're getting these angles from. Do we have parallel lines in this picture? I want you to mark it. This goes with this, and this goes with this. That's how you know that those two triangles are similar to each other, is by angle, angle. Now that they're similar, let's find ourselves a scale factor. Let's find two sides that correspond to each other, and you know both their lengths. What do you got? 16 and 14, well, they're from the same triangle. 16 is this side length. It goes with 14, which is that side length. Are they both from the blue triangle, right? The two triangles we're talking about is the blue triangle and the green triangle. Do you know a side from the blue and one from the green that correspond to each other? Which ones? 16 goes with 6. So how do you want to write your scale factor? 16 over 6 or 6 over 16? 16 over 6. That's my scale factor. Does it reduce to what? 8/3. Let's find x. So I'll start with my scale factor, 8/3, and that will equal whatever what, baby? What corresponds with the x? X is what I'm finding. 14 over x, you all good with that? Big over little. 5.25, is that right? Goody? Find y for me. Eight thirds is 10 over y or y over 10? Big over little. So now 3 times, there would be 6, 3/4, so 0.75, is that right? Yeah. Excellent. If you have kind of followed a sheep, the next one is one you really want to pay attention to. First thing, can we prove the two triangles similar? Which way? Because of the what? So I'll mark it for me. Yeah. They're similar. Let's find ourselves a scale factor, hey? Let's find ourselves a scale factor. Two sides that correspond to each other, and you know both their lengths. What do you think about 24 over 15? Not quite. I think we can all realize that this whole length is what we need, correct? And how long is that? 39. So my scale factor is 39 over 15. Can it reduce? Let's say you didn't know. Would it matter? If you don't reduce it, will you still end up getting the correct answer by the time you're all said and done? Yeah, but it does reduce. 3 goes into each one of those. So reduce that by a factor of 3 for me. And what do you get? 13 over 5. Excellent. That's the part I feel you could still be pretty successful at. Maybe we make a mistake, maybe we don't, right? But it's very successful. The next part, find an x that is not so easy. I need this. I need this, right? What I'd like you to do is represent that for me. You and Pal discuss and tell me how long that is. Now, what I'm about to say is not trying to insult anyone, but dear friends, how did you get 39 over here when this was 24 and this was 15? You add those together, right? Here's what most people put over here, though. They put 10x. That is not 10x, because what are you doing with the 10 and the x when you write it like that? You're multiplying those together. We don't want to do that. We want to add them together, so what should I put over there? 10 plus x is fine. I'm a big fan of x plus 10. I like to put it in standard form, variable first, number second. If you put 10 plus x, it's the same thing, but try to put the variable first. Sound all right? Let's find ourselves what that is. Scale factor, 13/5. That'll be proportional to big over little. What's my big guy? X plus 10 over the 10. Cool? Right here, I hope you know what 13 times 10 is. What's 13 times 10? Question, do you need to do the distributive property here? So if you can do it without writing it, I'm fine with it. If you need to write it with the parentheses, but very, very careful. That would be 5x plus 50. And that is 80 equals to 5x. And x equals what? 16. Any questions on that one before we move to the last one? Tricky, 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 tricky. All right, let's go to the last one. Prove them similar to me if you can. If you can't do it, that means then you can't find x. So see if you can figure out if those are similar to each other. I watched the people do this in class very well. We do need to do that. The whole thing over there is 18, and the whole thing over here is 12. Can I do side, side, side? How come? Only have 5 of the 6 sides, right? I'm missing this one down here, all right? Can I do angle, angle? Like that's what we did on the previous two. This is the same as this, and this is the same as this. Can I do that? Why can't I do that? Those aren't parallel to each other. So the only thing that I could try is side, angle, side. Can I get an angle anywhere? Where at? Shared angle up there by the reflexive property. That's still not enough. Just because it's possible to do side, angle, side doesn't mean that those corresponding sides are proportional. 18 over 6. Don't those correspond to each other? What do you got? 18 over 6. 3. 12 over 4. What do you got? So are these similar? So scale factor, what do you got for me? What's my scale factor? Don't just put a 3. It needs to be a fraction. What? 3 over 1 is my scale factor. Let's find x. What does x correspond with? So x over 20 or 20 over x? And a lot of people ask, it's like, well, duh, man, if you know it's like a 3-to-1 ratio, can't you just take the 20 times 3 and get 60? Yeah, but I'm asking you to do it by way of proportion and et cetera, because sometimes you got to divide by the 3 instead of multiply it by the 3. So just set it up as a proportion. Okay? Boy, if we were done here, wouldn't that be awesome? Here's the thing. On the bottom of this practice worksheet, I want you to copy this down. Redrawing pictures. There's some rules. I just want you to write it down first, and then I will discuss how to do it while I pass out the papers here. But you might not understand what the heck this says. I'll explain it here later. So please write this at the bottom of your practice sheet, because the problems on the homework, muy difficult. If difficult problems present us, it is to our advantage to probably redraw the picture. Let's go to the homework, and let's try number 1 right here. I do not feel that this problem is so difficult that it needs to be redrawn, but it's an easy one to explain what I'm trying to say. Okay? First thing you do is big and little. And do you see that the two triangles do not look identically the same? This big triangle, please tell me you understand what I mean when I say it's like pointing to the right. Do you see how that thing like points to the right? And doesn't this guy point to the left? You with me on that? Not looking exactly the same. So here's what I want to do. Rules to redraw pictures. First thing, make the little triangle point the same as the big triangle. So check it out. Watch this. Here's my big triangle. I'm going to make a new sketch right here. Doot, doot, doot. Do that. Do you see this red triangle that I have redrawn right here? Is it pointing the same way as the big triangle? Yes. I just made the new little, you can call this NL if you wanted to. That's the new little triangle. I'm making it point the same way. Step 1, accomplished. Step 2, put the big angles in the same place into the new little. That is hard for people to understand what I'm trying to say. Take the angles from the big triangle. See this guy? Isn't this the big triangle? Do you know what angle this is right here? How much? Put it in the same place into the new little triangle. Where should it go? Right in 1, 2, or 3. Where should it go? It should go in 3. The same corresponding position. Boom. I'm going to put right there. See this guy? Isn't he 50? Put it right here. Same place, 50 degrees. See this X? We're not going to put an X right there because that's something different. But all I did was a 90 and a 50, and boom. Sound okay? Here's what we should have done first. Before you want to redraw it, we should have saw maybe, no, we do want to redraw it. So, yeah, we're all right. My bad. Put the big angles in the same place as the new little. Check. Put the vertices from the old little into the new little in the right place. When I say vertices, that means the letters of the triangle. Old little, isn't this the old little triangle? Isn't this the new little triangle right here? Vertices, R, S, and T. Which one was the 90? So shouldn't the T go right here, next to the 90? You with me on that? 40 degrees is what this one is. And in my new little, I don't have a 40 degrees. But if this is 90 and this is 50, how much is this one going to be? If this is 90 and this is 50, how much is this one going to be? So 40 degrees is R. Where's this one going to be? What is this? R. And then finally, S is the last one. Shouldn't that be S right here, which isn't this 50 degrees in the first place? Yes or no? So step 3, checked. Step 4, put the side lengths in the correct place. I'm now going to take this new little and find all the side lengths. Right here, highlighter, S to T. Do you know how long it is from S to T? How long is it? It's 3. So I'm going to put a 3 right there. Right here, isn't this S to R? How long is it from S to R? A. And R to T, how long is it? B. Done all 4 steps, correct? Then I lightly cross this guy out. I don't want to see him. You don't want to black him out because you might need some information, especially when they ask you to find Y, and you're like, I don't know where Y was. Wasn't Y really right, Y was really right here. Is that all right? Then let's answer these questions. Are these similar? Yes or no? Side, 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 angle, side, or angle, angle. What do you think? Are they similar? Look at these two now. It's so easy to tell. Are they similar? Yes or no? Yes. Method. Angle, angle. Triangle ABC. Now it's a piece of cake. Doesn't ABC go this way? Doesn't this one look exactly the same as that one? Shouldn't it be just like this? What's triangle ABC similar to? Triangle STR. They already put the triangle symbol there for you. Then you find X, you find Y, you find A, you find B by way of proportions and etc. and corresponding angles. Here's what I want to go to next. I don't think that all of these problems need to be redrawn. Let's go to the next page. Number 6. I want you to redraw that one for me. Circle it. Let's do it right now. Okay? Let's do it together. Big and little. Look at those steps that you wrote on your practice sheet. And I'm telling you that this test is either easy or hard. When we take this test, if you know how to redraw triangles, it will be easy. If you don't know how to redraw the triangles, you won't make it. I tell you, you'll flunk the test. Okay? So if you have a question, ask. Step 1, what do we got to do? Make the little triangle point the same way as the big triangle. See the big triangle? Isn't he pointing to the left, if you will? I'm going to draw a whole exact picture that looks just like it. New little. I made my little triangle point the same way as the big one. Good deal? What's step 2? Big angles in the same place. Big angles. Here's the big triangle. Here's the 90. Shouldn't that go right here? Right? Here's a single arc mark. Shouldn't that go right there? Yep. Finish. Try step 3. What's step 3? Vertices from the old little into the new little. Which one was the 90? R, so wouldn't that go right there? Which one was the single arc mark? Wouldn't that go right here? And A had no place to play. Wouldn't that be the last one right there? What's the last step? Step 4. Put all the side length. I don't have any, so that means I'm done. Then cross this guy out. Now these two, real easy. Real easy. Are they similar? Yes or no? Yes. Which method? Angle, angle. And then it says triangle ABC is similar to. Doesn't ABC go around like this? ABC. Then this one's got to go the same order. WRA. Done and done. I do not feel that every one of these problems needs to be redrawn. Wait. I will tell you which ones to redraw. Okay? I do think that you should redraw number 10. Circle that. Number 10, I would highly recommend redrawing it. That's the hardest problem on there. I also think you should redraw number 13. The rest of them, I feel that you can get away with just looking at the two pictures and comparing them. Okay? Once you've done this, you'll probably figure out why I want you to redraw them and why I don't. Here's some other things you need to know. See this problem, number 3? Does that look like a bow tie to you? Hang with me here. Yeah. Does that look like a bow tie? Yes or no? In a bow tie, these sides always correspond to each other. In a bow tie, those guys on the outer edge always correspond to each other. Sound good? The other thing I will tell you is how many no similarities there are on this whole worksheet. There are 2 no similarities. There are only 2 that you will say no to. It means you can't prove them similar. If you need some help, I would be happy to help you.